All right, so what we're going to go through now is the base graphs. It's a 6.3. We're going to look at the graphs of sine, cos, and tan as well. Most of the stuff at the beginning is going to be familiar to you. Perhaps the graph about tan and the characteristics about sine, cos, and tan at the end will be new. So feel free to kind of skip through as much as you want. But what we have here is the graphs for sine and the graphs for cos. And we have radian measures all across the top, all for one whole revolution going from 0 to 2 pi. So the degree measures for each of them, as we know, they're all going up by 30. And in order to get the values that are underneath, what we do is we take sine and we input the number into our calculator. So you put things like sine 0 and so on, and we would get 0. Sine 30, when I put that into my calculator, I'm going to get 0.5. Sine 60, when I put that into my calculator, or if we have radians on, sine pi over 3, we're going to get 0.87. Sine 90, we get 1, and then it goes back in the opposite direction, 0.87, 0.5. back to 0, and then it goes down on the negative side, negative 0.5, negative 0.87, negative 1, back negative 0.87, negative 0.5, and back to 0. So if I'm to sketch what this graph looks like in terms of radian, so as we put these onto our graph, each of these is pi over 6. This will be 2 pi over 6, which will be pi over 3. And then 3 pi over 6 is just pi over 2 if we were to reduce it. So they're all going up by a factor of pi over 6. So if I'm plotting our points, we have a dot at 0 and 0, pi over 6 and 0.5, pi over 3 and 0.87, and so on. We would get a graph that looks something like this. And that's the sine curve, which starts at the origin. So that has an x-intercept at pi and goes on. And then I'll do cos and I'll be back in a second. Fill in our cos points, as you know. We would get a graph that starts at 1. Whoops. And it would be a curve that looks something like this. So that's our sine and that's our cos graph. So those are two primary ones that you're probably familiar with at this point for one cycle. That's from 0 to 2 pi. It would continue on as it goes to the right, same with sine and cos. It's just a wave that continues on forever. So what we did in the past was we said, well, we have base points. Our base points were, well, we started here. And these are the points that we use for our sketching. And we're going to be looking at sketching in the next one. Basically, same ones you would have used back in grade 11, where x is 0, 90, 180, 270, and 360. And as long as I have those base points, I'll be able to sketch or even transform later on all of our main points that we have. So those are two that we're familiar with. Let's continue down to the next one. So what about tan? So for the tan graphs, there's two things that I can get for my tan values. I can either put the x values into the equation y is equal to tan x and get values. Another way that I can do that is we know the identity tan theta is equal to sine theta divided by cos. So really what I could do up here as well is take my values of tan by finding the value of sine 0 divided by 1. And then 0.5 divided by 8.7 and so on. Regardless, we're just going to fill it in the same way just to see what the graph looks like. And I'll just do that now. I'll be back in a sec. All right, so here we are with our tan values, just combinations of 0, 0.58, and 1.73. One thing that you might notice is that there are two values that are undefined. Why are they undefined? Well, remember, tan is sine divided by cos. So let's see what happens at pi over 2 and 3 pi over 2. Well, at pi over 2, we have 1 divided by 0. So you can't divide by 0, that's why it's undefined. Same thing happens at 3 pi over 2. We have negative 1 divided by 0, which is also undefined, right? We can't have that 0 on the bottom of a fraction. So what happens in that case, if I'm to sketch these, is that at pi over 2, we have vertical asymptote, same as what we saw before. Same thing's going to happen at 3 over 2. Vertical asymptote happening here. And what I'm going to do is just fill in these values of what we've got. I'll use orange for this one. So we have a dot at 0 and 0. We have a dot at pi and 0.58, so about right here. Actually, make it a little bit lower. So somewhere around here. And the next one, 1.73, so somewhere way up here. And what happens is the graph looks something like this in this section. So what's happening in the middle? We'll make a scale, -1, -2. In the middle we have -1.73, so down here, 0.58, 0, 0.58. And what we have happening is kind of like a twist happening through the middle here. And then we'll see the same thing happen on this side. So that's what one cycle looks like. You can imagine that will continue on forever. So there'll be another section over here, probably another vertical asymptote happening way out here. Same to the left side. You can imagine the graph would look something like that. We continue on, and vertical asymptote on the left. However, for one cycle, that's what we got. So that's what the tan graph looks like. Doesn't look like a wave like the sine and cos. However, it does repeat over time. It is a periodic graph. So let's look at some characteristics about these things. The sine graph. What is the domain of the sine graph? What are the x values? Well, it continues on forever. So it had XER. Continued on forever to the left and to the right. The range value for sine were all values in between -1 and +1. And included -1 and +1. The max value for sine was 1. Minimum value is -1. It's always the same. The amplitude, that's the distance from the middle to the top. That's also 1. So just to keep in mind, what is the amplitude? Amplitude is the distance from the center to the top. So this distance here, called the amplitude, it's 1. It's also the distance from the middle to the bottom, which is also 1, right? Just a distance. Basically what it does is how much it oscillates over this equation of the axis. That's that line that would split it right in half at y is equal to 0. So let's continue down here. Next one is that equation of the axis. Well, that happens at y is equal to 0. Just drew that one on with the green line. The period for these graphs are either 360 degrees, or we could say 2 pi if we want to write it in radians. For cos, it's all exactly the same. Nothing's different. X is an element of the real numbers. The range is between -1 and +1. The maximum value is 1. The minimum value is -1. The amplitude is also 1. Equation of the axis is also 0. And the period is 360 or 2 pi. Where we do get into a little bit of trouble is working with our x-intercepts, because x-intercepts happen quite a bit. So x-intercepts happen for the sine graph, the blue one here. Maybe I'll use pink. Happens at 0, happens at pi, happens at 2 pi. You can imagine where the next one's going to happen. So if it's at pi and then 2 pi, next one will be at 3 pi, and then 4 pi, and then 5 pi, and 6 pi, and so on. So how do I write that? Well, what that is just a sequence. If you remember how these sequences work, so it's an arithmetic sequence, which says A is the starting one. So where's the first one happen? Well, it happens at 0. Plus n minus 1. So that's just where is the first one, second one, third one, where does it happen? That's the n value. I want to know where the fifth x-intercept is. So I put in a 5. And d is the distance between them. So in this case, they're spread out by pi because it's 0, 1 pi, 2 pi, 3 pi. Like so. So that would be an expression to show where the x-intercepts are going to be, just using that arithmetic sequence of numbers, which you learned back in grade 11. So let's write the one for the cos graph. So where are these ones? Well, first one happens at pi over 2. Next one happens at 3 pi over 2. So that's 1 full pi away. Next one after that will be at 5 pi over 2. And then 7 pi over 2, and 9 pi over 2, and 11 pi over 2. So they're all 1 pi away from each other. The only difference is this one starts at pi over 2. So that's the first one. So that's our A value. So I'm going to write that out here. So A is the first one. Where does that happen? Pi over 2 plus n minus 1. And how far apart are they? They're pi apart from each other. I can distribute inside and simplify if we wanted to. We don't need to. Next, y-intercept. Well, that's just where the graph starts. So the sine graph, it's the one in blue on the left, starts at 0. The cos graph, where does it start? Well, it starts up at its maximum, which is 1. And let's continue with tan. So tan's a little bit different. So the sine and cos is probably ones you've seen before. Probably not that x-intercept interval parts. But let's look at this. So what is the domain here? So the domain is that x can be any number. However, x cannot be pi over 2. X cannot be 3 pi over 2. I know if I continued on, x cannot be 5 pi over 2. So the range is an element of any number. However, not every pi starting from pi over 2. So let's look at that. So if I want to write this, say x is an element of the real numbers. However, x cannot be equal to, and I can write out our sequence down here. First one happened at pi over 2 plus n minus 1 pi. And I can simplify, distribute inside if we want to. But that's the idea. N cannot be those values. Another way that you could put this is n cannot be 2 pi, or pi over 2, plus pi. Some places will say k. So say, where's the first one? Where's the second one? You can put in that value for k and add it. So if I want to know when k was 0, well, it would just be pi over 2. When k is 1, well, I can add them together. It would be 3 pi over 2. K was 2. So just as k is integers, we can find out those. But same idea. So what's the range of this one? Well, we know it goes all the way down from negative infinity to positive infinity because it has those vertical. So you could say y is an element of the real numbers. Either or. Both are the same. Maximum value, well, there is none. It goes all the way up to infinity. Minimum value, well, it goes all the way down to negative infinity, so there's not one. Amplitude doesn't apply because it's not a wave. Equation of the axis does not apply because it's not a wave. The period of this function. Now you might say it looks like it's 360, but for one cycle, how long does it take to complete one cycle? Well, I see one full cycle in here. That is from pi over 2 to 3 pi over 2. Well, that's just pi apart. So 180 degrees, or pi. X-intercepts, well, I'm going to have to write that sequence again. So first one happens at 0, then it's at pi, then it's at 2 pi. So I can write, first one happens at 0, that's a, plus n minus 1, and they happen pi apart from each other. Very similar, just different starting spots. And finally, the y-intercept, where does this one begin? Well, the tan graph, when x is 0, is 0. So this was just an introduction into what the graphs look like for sine, cos, and tan, as well as some of the characteristics for them. And there's a couple questions at the bottom, but a very short section for this part of the chapter. So that's it for this section, and we'll talk to you soon.